Hello students, today I am going to explain about the module 2 of first part equilibrium of forces. Okay, so I have provided you the notes about the equilibrium of forces through Google Classroom as well as on WhatsApp. I think you have gone through with the notes. So the basic theory part I will not be covering over here. So I'll start with the numerical problems. Before moving on to the numerical problems, first we'll have a glance on the your Lamis theorem. So already you know that the Lamis theorem is generally applied when you have three forces, concurrent forces acting in a single plane. The body is in equilibrium. Okay, so the Lamis theorem states that the magnitude of each force is proportional to the sine of angle between other two forces. So in this case, if I consider the F1 force is proportional to the sine of angle between the other two forces. So we can see that the other two forces are F2 and F3. The angle between them is alpha. Okay, so F1 by sine alpha. Similarly, if I consider the F2 force, other two forces are F1 and F3. The angle between them is beta. So F2 by sine beta. Similarly, F3 by sine gamma. Okay, so this is your Lamis theorem. Generally, when you are solving the numerical problems, if you have system of forces are consist of three forces, then the solution of the member of force can be calculated by using the Lamis theorem, which I have explained now. Okay, if the forces are more than three, then that time we need to apply the condition of equilibrium. So condition of equilibrium for coplanar concurrent force systems are summation of fx equal to 0, summation of fy equal to 0. Whereas for non-concurrent force system, then there will be additional condition, that is summation of m naught is equal to 0. But only module 3 covers the concurrent force system, so we'll be talking about only two conditions, which is summation of fx equal to 0 and summation of fy equal to 0. Okay, so before moving on to the numerical problems, you should know the Lamis theorem and the condition of equilibrium. Now I'll start with the one. uh, okay, before moving on to the numerical problems, we need to know the free body diagram. So what is free body diagram? Generally we'll be having a space diagram and the free body diagram. Space diagram is nothing but generally the problem will be given, or the figure will be given in the problem, which consists of a sphere, a cable, or a body resting on some surface connected with the wires or some loadings. That will be a space diagram. When we talk about the free body diagram, so all these supports will be replaced by the reactions, and the weight will be shown in a point load, and other forces which are connected with it. If it is connected with a cable, then tension will be shown, other reactions will be shown. If you see over here, this is called the space diagram. A sphere is hanging through cable and the sphere is attached to the wall. So when the sphere is attached to the wall, this surface will produce some reaction on the sphere, and this cable will produce or induce tension in that. Okay, if I draw the free body diagram of that, so I'll just draw a dotted line of a sphere. Then there's a self weight of the sphere, which is your load or the weight of the sphere. Then there's a reaction produced by the surface, and then there's a tension induced in the cable. So this is called the free body diagram. Similarly, if I talk about, or if I take one more example for clearing about the free body diagram or concept of free body diagram, you can see that I have three spheres which are rested on the surface. One sphere is above the 2 and 3 sphere. So if I draw the free body diagram of that, so first this will be a sphere 1, this is sphere 2, and this is sphere 3. Okay, so you can see that the sphere 2 is attached to the your sphere 1, sphere 3, and there is a reaction produced by the surface. Similarly, sphere 3 also have the same reaction, whereas this peer 1 have reaction over here, reaction over here, and there's a self-hit. If I draw the free body diagram of peer 1, there's a reaction produced by this peer 1 to 2, that is R12. That means the spear 1 produces a reaction toward the spear 2. Similarly R13, and there's a self-hit. Whereas in the second spear there is a reaction produced by the second spear to the third spear is R23, then R21, then there's a self-hit. Here I have missed one more reaction which is produced by the surface, so you'll get one more reaction over here, as well as here also you'll get one more reaction. So this is your free body diagram. So generally the free body diagram, if you have the supports, we remove the supports and replace them with a reaction. Then the applied forces, if there is applied forces, then you have to show the arrow for the applied forces, then the self-weight of this. So all these consist of free body diagram. Okay, so we'll move on to the simple problem for calculating the member forces in a cable. So you can read the question. Two cables are connected at A and C as shown in figure, and a force of 20 kilonewtons is applied at a B. So we need to determine the forces in the cable along BA, which is nothing but this force, and BC along this cable. So for doing that, first what we have to do is we have to draw the free body diagram. So for doing that, what we'll do, we'll cut the section over here. So generally this cable have the tension in that, as well as this cable has tension. So if I cut this, then we'll get the free body diagram like this. Okay, so the tension TBC, then TBA, TBC and TBA. So which makes 45-degree inclination with respect to horizontal. This makes 30-degree inclination with respect to horizontal. So in this case the forces are of 3. So given system of forces consists of 3 forces, so we can apply Lamè's theorem to solve the member forces. Okay, so for solving the problem by using Lamè's theorem, we should know the angle between all the forces, between the TBA and TBC, and TBC to 20 kilonewton, TBA into 20 kilonewton. So we need to calculate the angle for that. For doing that, if I consider this angle, which will be 105 degree, we know that this horizontal plane makes 180 degree inclination, in that this is 30 degree and this is 45 degree. So if I deduct 45 minus 180 minus 180 minus 30 minus 45, then I'll get 105 degree angle between these two forces. Similarly, if I calculate the angle between these two forces, so this is 90 degree plus this 30 degree, so total will get 120 degree. In this case, this is 90 degree, this is 45 degree, so total will be 135 degree. So we'll get all the angle between the forces. Now we can use Lamè's theorem to calculate TBC value, that is tension in BC cable, and the tension in BA cable. Okay, so I'll write the Lamè's theorem, which says that the magnitude of each force is proportional to the sine of angle between the other two forces. We know that the angle between the TBC and TBA is making 105 degree, so 20 by sine 105 equal to TBA sine 135, TBC sine 120, as we have seen in this one. So 20 by 105, TBC by 120 sine of 120, TBA by sine of 135 degree. Okay, so if I take these two terms, sine 20 by sine 105 degree equal to TBA by 1 sine 135 degree, so I'll keep TBA as it is and I'll take sine 135 on the other side. If I take it, it will be 20 into sine 135 degree divided by sine 105 degree. If I calculate, then I'll get TBA value as 14.64 kilonewton. Similarly, if I calculate TBC value by considering these two elements, so TBC will be 17.93 kilonewton. Okay, like this we can calculate the member forces for the given figure. Now we'll take the next problem, where a problem consists of four forces. So we can use the condition of equilibrium to solve the problem. So you can see that, determine the forces in a string. String is nothing but your cable shown in figure. Okay, so this is the given problem or the given figure. So if I draw the free body diagram of that, so I need to cut the section at this level and at this level. If I cut this section, I'll get the free body diagram like this. These are the two forces which are given. Then this is here the F2 force and this is here F1 force. As we can see that this force makes the 30-degree inclination with respect to vertical. If this makes 30-degree, then if I draw the vertical line at this point, then angle between these two forces will be, or the between these is 30-degree, which I have shown over here. Similarly for this, if this is 30-degree, then this will be 30-degree. So again I'll get the 30-degree inclination. Okay, so after drawing the free body diagram, we can see that the number of forces in this problem are more than 3. Then that time we cannot apply the Lame's theorem for calculating the member forces. So what we have to do is we have to take the condition of equilibrium, which is summation of fx equal to 0 and summation of fy equal to 0. So we know that to calculate summation of fx equal to 0 and fy equal to 0, first we need to resolve the forces which make certain inclination with respect to horizontal or vertical. So for doing that, what you have to do is I have to resolve this force along the vertical component as well as the horizontal component. I'll consider this as F1 force. If I resolve this force along the horizontal direction, then it will become F sine 30, because the force moving away from the angle, so the force component will become F1 sine 30. Similarly, if I resolve on the vertical component, then it will become cos 30, because we are moving the force towards the angle, so it will become F1 cos 30. Similarly, for this force, the x component will be sine, the y component will be cos. So I'll get F2 sine 30 and F2 cos 30. So these are the resolved component of the forces. Now we have to start with the first equation or the condition, which says summation of fx equal to 0. If I take the summation of fx equal to 0, then the number of forces in the horizontal directions are, this is the 200 Newton 1, F1 sine 30, F2 sine 30. These are three forces which are acting in horizontal direction. So if I take the summation of fx equal to 0, then I'll get 200, which is moving right side, so I will take as a positive. So whereas F1 sine 30 as well as F2 sine 30 moving opposite to the 200 Newton force, or I can say in a leftward direction. If it is in leftward direction, the sign convention what we have taken as minus for that. So I'll get minus F1 sine 30 minus F2 sine 30, which is equal to 0. Then what I'll do, I'll take the sine 30 common between these two forces. If I take minus 30 common, then I'll remain with the F1 plus F2. So then I'll take 200 on the other side and sine 30 as well as on the other side. So I'll get F1 plus F2 is equal to 200 by sine 30. So 200 by sine 30 will be 400. So this will be the first equation. F1 plus F2 is equal to 400. Similarly, if I calculate summation of Fy, the 200 is acting downwards, so minus 200. F2 cos 30 is also acting downwards, so minus F2 cos 30. Then the F1 cos 30 is moving upward, so we'll take it as a plus. So minus 200 plus F2 cos 30 plus F1 cos 30. Among these, I'll take cos 30 as a common. I'll remain with F1 minus F2. I'll take 200 on the other side. It will become plus 200. So I'll get F1 minus F2 is equal to 200 cos 30. So the equation 2 will be F1 minus F2 is equal to 230.94. If we solve equation 1 and 2 simultaneous equation by using calculator or
by other mean. So we'll get F1 as a 315.47 Newton and F2 as 84.53 Newton.